Today we're looking at notes 8-6, the conjugate root theorem. So the conjugate root theorem is found on page 369 in your book, and basically what it states is that imaginary and square roots come in conjugate pairs. And what that means is if 1 plus 2i is a root, then 1 minus 2i is a root also. Okay, also if negative 7 minus 4i is a root, negative 7 plus 4i is a root. So notice the sign change happens on the imaginary number, okay, not on the regular real number right out in front. Likewise with our square roots, if 3 plus square root of 5 is a root, then 3 minus square root of 5 is also a root. Okay, if negative 8 plus 3 square root of 2 is a root, negative 8 minus 3 square root of 2 is a root. Okay, and similarly, if 6i is a root, negative 6i is a root. If negative square root of 7 is a root, square root of 7 is also a root. Okay, but if 5 is a root, negative 5 is not necessarily a root because 5 is not imaginary or a square root. So this theorem only works for square roots and imaginary numbers. Okay, so to refresh our memory on some old stuff that we've been doing, I want you to practice constructing a polynomial of second degree with roots -2 and +3. So remember, if these are my roots, that means x equals -2 is an x-intercept and x equals 3 is an x-intercept. When I go backwards to make that a factor, I move the number on the side with the x, which is going to change the sign. So this would become x plus 2, and this would become x minus 3. And then what I go ahead and do to make the polynomial is I FOIL these. So x times x is x squared, x times -3 is -3x, 2 times x is 2x, and 2 times -3 is -6. So my polynomial would be y equals x squared minus x minus 6. And then I'm all done. Okay, so that is review, stuff you've already done. Let's talk about some new stuff. So, number 2, use the conjugate root theorem to construct a quadratic equation with root x equals -i. Okay, so here's your deal. It says quadratic equation, that means there should be 2 roots. Quadratic is second degree. It gives you 1. Well, it's kind of giving you 2, because if -i is a root, what else does that mean as a root? If x equals -i is a root, then x equals I is also a root. So I have x equals -i, x equals I. This is going to become the factor x plus I. This is going to become the factor x minus I, and then you go ahead and FOIL. So x times x is x squared, x times -i is -ix, I times x is positive ix, I times -i is -i squared. And then you have these two middle terms that you can combine, and look at that. They're one's positive, one's negative. They're just going to cancel out completely. So you would have x squared minus I squared, but hopefully from long ago you remember I squared equals -1. So this is the same thing as x squared minus -1, which is going to turn to x squared plus 1. Okay, so slap a y equals on that, and you've got your quadratic equation. X squared plus 1 has the roots -i and +i, plus or minus I. Okay, so now let's do another one. Use conjugate root theorem to construct a cubic equation with roots 1 and 3i. So cubic means third degree. There should be 3 roots, and there are. 1, 3i, but if 3i is a root, what else has to be a root? Well, -3i. So what we're going to do is we're going to write x equals 1, x equals 3i, x equals -3i. Okay, so this is going to be x minus 1, this is going to be x minus 3i, and this is going to be x plus 3i. Okay, please heed my advice when I say if you ever have a real number and imaginary numbers in factors, you always want to multiply the conjugate pairs together first. If you start by multiplying this in, it's going to get ugly fast. But if you multiply these conjugate pairs together, a lot is going to cancel and it's going to end up a lot nicer than you think. So let's start with foiling these two. So I've got x times x, which is x squared. Okay, x times 3i, which is 3ix. Negative 3i times x, which is negative 3ix, you can already see. And then negative 3i times 3i would be negative 9i squared. So if you've multiplied your conjugate pairs together correctly, the middle two should always cancel, and they do here. So I also want to make sure I keep dragging down this x minus 1, drag it down, okay, and I've got this still here. So keep dragging down this x minus 1. This turns into x squared minus 9i squared. Okay, and then from before, I squared equals negative 1. So this is going to turn into a negative 1, and negative 9 times negative 1 is going to be a positive 9. So I'd have x minus 1 times x squared plus 9, and then I FOIL again. Okay, so x times x squared is x cubed. X times 9 is 9x. Negative 1 times x squared is negative x squared. And negative 1 times 9 is negative 9. So I need to slap a y equals on it, and I need to put it in standard form. Y equals x cubed minus x squared plus 9x minus 9. And then I'm done. Okay, so now if you are in pre-AP, this is where you will continue. If you are not in pre-AP, you can shut off this video. All right, my pre-AP folks, use conjugate root theorem to construct a third degree polynomial with roots 2 and 1 minus I. This is where it gets real fun. So x equals 2 and x equals 1 minus I, but it's third degree, which makes sense because if 1 minus I is a root, then 1 plus I is also a root. Okay, oops. So now we're going to construct our factors. So this would be x minus 2. This, watch closely, both of these need to come over. So x minus 1 plus I, both of those will change signs. And then x, this is going to turn to a minus 1 minus I. Okay, so be very careful about sign changes on both. Both need to change signs. Okay, so now we need to, like my advice before, you need to multiply your conjugate pairs together first. So this is really fun, okay? So x times x, we need to distribute this x throughout, and don't forget to drag down the x minus 2. X times x is x squared. X times negative 1 is negative x. X times negative I is negative ix. Then we start with the negative 1. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times negative I is positive I. Then I go here. I times x is ix. I times negative 1 is negative I. And then I times negative I is negative I squared. Hopefully a lot will cancel and you'll see it does. This negative ix and this positive ix cancels. What else cancels? This I and this negative I cancels. So far I'm dragging down the x minus 2, and then I've got x squared. This negative x and this negative x combine to negative 2x. And this 1 and this negative I squared combine because I squared equals negative 1. And if I squared equals negative 1, then minus negative 1 would turn to plus 1. So 1 plus 1, which would give me 2. Okay, then I go ahead and do some more math, all right? So distribute this x. So x times x squared is x to the third. X times negative 2x is negative 2x squared. X times 2 is 2x. Okay, and then I go negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is positive 4x. And then negative 2 times positive 2 is negative 4. So slap a y equals on it, you get y equals x cubed minus 2x squared would be minus 4x squared, and then plus 2x plus 4x would be plus 6x, and then minus 4, and you're all done. Okay, I do have one more example for you. I want you to construct, use CRT to construct a third degree, no, let's make it more fun. Fourth degree polynomial with roots, right? With roots 8 plus square root of 2 and 5i. Ooh, this is fun. Okay, so why is it fourth degree? Well, it's fourth degree because each of those has conjugate pairs. Okay, so I'm going to have x equals 8 plus square root of 2, x equals 8 minus square root of 2, x equals 5i, and x equals negative 5i. Okay, so again, watch carefully for this factor here. Both of these are going to need to hop over, so it's going to be x minus 8 minus square root of 2. This is going to be x minus 8 plus square root of 2. And this is going to be x minus 5i and x plus 5i. So you would want to multiply these two together and these two together first, and then multiply them together. So x times x is going to give me x squared. X times negative 8, negative 8x. X times square root of 2 is going to be plus x square root of 2. Negative 8 times x is negative 8x. Negative 8 times negative 8 is positive 64. Negative 8 times square root of 2 is negative 8 square roots of 2. And then negative square root of 2 times x is negative x square root of 2. And then negative square root of 2 times negative 8 is positive 8 square root of 2. And then negative square root of 2 times positive square root of 2 would be negative square root, or no, it would be negative square root of 4, which would be negative 2. Okay, the square roots cancel each other. All right, so now hopefully a lot should cancel. So let's start looking at all this stuff. Yes, this and this cancel. Okay, what else? This and this cancel. Nice. Okay, and let's go from there. So I've got x squared minus 8x combines to minus 16x. And then this 64 minus 2, which would be plus 62. Okay, so let's see if we could squeeze. So that was this. Let's see if we could squeeze this right here. So x times x is x squared. X times 5i is 5ix. And then negative 5ix. And then negative 25i squared. Okay, so again, conjugate pairs, when they're binomials, the middles cancel. That's super easy. So I've got x squared, and then that turns to a plus 25. And then from here to multiply this together shouldn't be too bad, right? You're going to do x squared times x squared, which is x to the 4th, x squared times 25, which is 25x squared, negative 16x times x squared, and I'm running out of time, so I don't want to keep you negative 16x cubed. Why don't you finish this problem off for me, bring it ready to go to class.